Hello students, welcome to Saurabh's classes. Today we'll be solving the IIT JAM Mathematical Statistics question paper of year 2018. Today we'll be solving question number 18. In question number 18 it has been said that let M be a 3x3 non-zero skew-symmetric real matrix. Now if I is the 3x3 identity matrix, then option A, M is invertible. Option B, the matrix I plus M is invertible. Option C, there exists a non-zero real number alpha such that alpha I plus M is not invertible. And option D is all the eigenvalues of M are real. So these are the four options. Now we have been given that M is a skew-symmetric matrix. So we can take an example of a skew-symmetric matrix of the formation 0 minus A minus B, A 0 minus C, B C 0. Okay, so this is the formation. So what happens in a skew-symmetric matrix? So in a skew-symmetric matrix, first of all the diagonal terms are 0. So basically we can write that AII is equal to 0, or A11 is equal to A22 is equal to A33. Those are all equal to 0. This is the first. And also A of ij is equal to minus of A of ji. So that's why you can see A of 1 2 is minus of A, which is the negative of this A of 2 1. So this is this skew-symmetric matrix formation. These are the conditions for skew-symmetric, and also this is non-zero. So now let us find out the value of determinant of M. So determinant of M will be given by minus of A into minus BC minus B into AC. So this will be equal to ABC minus ABC. This will be equal to 0. So therefore, since determinant M is equal to 0, therefore M is not invertible. So option A is not correct. So one option is gone. Now we have to find out I plus M. So now I plus M is given by 1 0 0 0 1 0 and 0 0 1 plus the matrix 0 minus A minus B, A 0 minus C, B C and 0. Upon addition, this will give us 1 minus A minus B, A 1 minus C, B C 1. Okay, so this is that. Now determinant of this matrix will be given by determinant of I plus M will be given by 1 into 1 plus C square minus A into minus BC minus A minus B into AC minus B. So this will give us 1 plus C square plus ABC plus A square minus ABC plus B square. So this will give us 1 plus A square plus B square plus C square. Now we know that ABC are not equal to 0. So this is not equal to 0. This is what we have got. So basically I plus M is invertible. I plus M is invertible. So option B is correct. Let us try to check for option C as well. Now option C has been given, option C is given as alpha I plus M. So now alpha I plus M is nothing but the matrix alpha minus A minus B, A1 A alpha and minus of C, and B C and alpha. So in this case the determinant will be given by determinant of alpha I plus M will be equal to alpha into alpha square plus c square minus a into minus bc minus a alpha minus of b into ac minus b alpha. So this comes down to alpha cube plus alpha into a square plus b square plus c square. Now if alpha I plus m is not invertible, then determinant of alpha I plus m is equal to 0. So that will imply that alpha cube plus alpha into a square plus b square plus c square is equal to 0. So that will imply, if we take alpha common over here, that will give us alpha square plus a square plus b square plus c square is equal to 0. Therefore either alpha is equal to 0 from here, or alpha square plus a square plus b square plus c square is equal to 0, or that will mean that alpha square will be equal to minus of alpha square plus b square plus c square. That will imply that alpha square equal to minus of a square plus b square plus c square. So that will imply now a square plus b square plus c square is a positive number. So minus of this thing will be a negative number, and that will imply that alpha square is a negative number, which will only be possible if alpha is a complex number. So that will mean that alpha does not belong to a real number in this case. Okay, so basically there exists no alpha for which, no real alpha for which alpha I plus m is not invertible. Okay, so option C is also not correct. Option C is not correct. And now for option D, let me tell you one more thing. Let me give a concept is associated word here. The concept is that all eigenvalues of m are real. Now we know that if m is a skew symmetric matrix, in that case the eigenvalues, there are 3 eigenvalues associated for a 3 cross 3 matrix. One is 0, and the other are complex numbers, which are complex conjugate numbers. So one real, which is alpha, and 2 are imaginary, which are complex conjugate. So we can see from here that all eigenvalues are not real for a skew symmetric real matrix. So after checking all the options, we have come down to that only option B is the correct option. So today we have solved question number 18 from the IIT JAM Mathematical Statistics question paper of year 2018. We will be solving the next questions in the subsequent videos. Till then, keep watching Softsource classes videos for more solutions and content. Thank you very much.